Wake up, we about to do 3 problems that we learned this semester. So here we go. This first one comes from chapter 9, and it says, when you reflect a figure across a line, does every point on the pre-image move the same distance? Well, first thinking at this, or looking at this, you would automatically think that the answer is yes, but it really isn't, because what we think it means is the whole entire figure moving the same amount from the y-axis. But really, if you look right here, it says every point. And when it says every point, it means each point. So let's say, for example, you have this figure right here, and as you can see, this is a square. And what I originally thought when I looked at this word problem was each one of these right here moves the same from here, from this y-axis. So it moves 1 over, 1 over, 2 over, 2 over. But really, that's not the case. What it's talking about is each individual point. And if the answer were to be yes, then that would mean that a point like this right here would go over here, and then only all the points would be on this line. And frankly, you can tell that that's not really a square. So definitely the answer to this problem is no. Every point does not move the same exact distance. Our next problem comes from chapter 10, and it's simply put, find the area of the shaded region. And looking at this, we know the diagonals of the smaller square are the same length as the line segment given, or the same degrees. So you can calculate the area if you know the length of the diagonal. The area is half the product of the diagonal. So what we would do is write A equals 1/2 times the diagonal times the diagonal. That calculated out equals 8 inches squared. There you go. That's your small square. So keep that in mind right there. Let's put that off to the side right here. So next, the diagonals of the larger square are twice the length of the diagonal of the smaller square. So you have to calculate the shaded the bigger square's area. This is what you do. So you do A equals 1/2 times 8 times 8. And that calculated out equals 32 inches squared. There you go. And so what you do from here is you subtract the areas to get the area of the shaded region. Simple. So you do A equals 32 minus 8. So A equals 24 inches squared. There you go. It's simple as that. All you're doing in this problem is subtracting this from this to get this right here. And that's basically all you're doing. So it's pretty simple. Moving on, we have our next problem from chapter 11. And this one says, there are 750 toothpicks in a regular sized box. If a jumbo box is made by doubling all the dimensions of the regular sized box, how many toothpicks will the jumbo box hold? Well, that's a good question. But first, we need to address that word problems are important. A lot of people try and put them off to the side, but it's essential to be able to do this, because not all of your problems are going to be like this here in chapter 10, where they give you something to do. This, you have to come up with it yourself. So let's get started. Each dimension is changed by the factor of 2. So the scale factor is 1 over 2. So we do K1 over K2 equals 1 over 2. There we go. And we also know that the ratio of the volumes are the same as the ratio of the third powers of the scale factors. So we would do volume 1 over volume 2 equals 1/3 over 2/3. There you go. And then that equals to 1/8. And that's your ratio. So from there, you do 1 over 8 equals 750 over x. So that equals x equals 8 times 750. And so x equals 6,000 toothpicks. So from there, you're done, right? You wrote the answer right here.
No!
Wrong. That's not the answer. A lot of people forget this, and what they don't do is write it in word form, or whatever you call it. I know it sucks, but you gotta do it, matey, because if you don't do it, then you're gonna get points marked off. So let's get started. We write, there are approximately 6,000 toothpicks in the new box. And there you go. There's your answer. There are approximately 6,000 toothpicks in the new box. So there you go. I hope you enjoyed this tutorial on the 3 problems we learned in the semester. We didn't learn only 3 problems, but this is just a small chunk that we learned. I hope you enjoyed it. Thanks.